What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at something called binomial expansion, specifically with surds. We might have seen this in algebra before, and again we're going to see that there's a massive overlap between our surds functions and what we've learnt in algebra. If you're on top of some of this expansion from algebra, I think you're going to find this lesson incredibly easy. So the idea behind a binomial expansion is legitimately in the name. The word binomial means we're talking about two separate terms, usually with a plus or a minus in between. And then an expansion, just like expanding that we learnt in like year 8, is just multiplication. So a binomial expansion is going to be two brackets with two terms multiplied together. We have to put this together with our surd knowledge. So we need to multiply the surds correctly by putting everything under the same root if needed. And then we have to collect like surds if possible. Remember to always be looking at some of these perfect surds, so root 16, root 25, root 36, because they will allow us to simplify the surd fully and then get full marks for every single one of these questions. So if we have something like this, root 3 plus root 5, all multiplied by 2 plus root 5. To do this, we're just going to use FOIL. And if you haven't heard of that before, please watch one of my other videos because I go into how this works in a lot more detail. But the first thing we're going to do is multiply the first two terms. So that's root 3 multiplied by 2, so it's just 2 root 3. Then we have to multiply the outside, so root 3 and root 5, so that becomes root 15, just with our surd knowledge. Then we've got our two inside terms, so root 5 multiplied by 2, which is 2 root 5. And finally, root 5 by root 5 is just 5, multiplied by itself. All we've got to do here is search for any like terms, and there aren't any. This is the complete answer, fully done. A lot of my students sometimes go, oh, root 15, I can break it into root 5 and root 3 and then add it onto something else. We don't have to do that. Because it's not a square factor, we don't need to break down the root 15. We can just leave it as is. So for this next one, we've got root 6 plus root 7 all squared. And I'll actually give you a mark if you show me exactly what this means. Because it's squared, I've got root 6 plus root 7, all multiplied by root 6 plus root 7. So now I'm doing my FOIL, so root 6 times root 6, which is just 6. Now I've got root 42, but I've actually got that twice because root 6 times root 7 is 42, and that happens twice. Finally, I've got to do my last term, so root 7 times root 7, which is equal to 7. Now I have to collect my like terms. 6 and 7 is just equal to 13, so I can put that up the front. And I have 2 root 42s, so I just write 2 root 42. 42 looks like one of those ones with a square factor. I was searching for a 4 or a 16, but it doesn't fit in, so this is fully simplified. Now we've got something that looks almost identical, except the term in the middle is a plus and a minus, not both pluses. So for this one, we're going to come up with an answer that's a little bit weird, and my next video is going to go in detail of why this answer looks so strange. So here I've got to do 2 times 2, which is equal to 4, and then I've got 2 multiplied by negative 7, so negative 2 root 7. Then the plus 2 root 7 is plus 2 root 7, and finally I've got the two 7s multiplied together, which is negative 7. Now I've got to collect my like terms. The important bit here is if I've got negative 2 root 7 plus 2 root 7, that's the exact same thing. And we know plus and minus cancel each other out. That means these two terms just disappear. They equal 0. Now I just have to do my 4 minus 7. That's what's left over. So my answer for this really complex surd is just negative 3. The reason some of my students do struggle with these questions sometimes is they're looking for surds. We've got surds in the answer. The whole topic is about surds. How can this just equal one whole number? Just by making sure that we understand that multiplying the same surd by itself will give us a whole number is incredibly important for this idea. Thanks so much for watching this lesson, and I'll see you later.